All right, let's go and get started. Let me get the sign-in sheet passed around. Okay, so there's that. So real quick, a couple things. So you all just turned in homework 6. I guess I ought to mention something. There was a few people that I guess maybe it was a little unclear on the homework assignment, but there was a few people that they wrote their script for problem 2, and then they just screen captured it and turned it in. But we actually need the M file, because the way the TA is going to grade it is they're going to take different input, run your file, and see if it works. So that's how it's going to work. And I mean, it wasn't just like 1 or 2 students, actually a few of you. So I would check your network drive and make sure the actual program is in the network drive. So I figured maybe it was a little unclear something on the assignment. So what I told the TA is, as I said, just hold off grading everybody until sometime later today. Maybe the TA will start grading it today. So if you haven't gotten your M file into the network drive, I mean, I would check and make sure it's there. Go ahead and put that in now. And maybe because it was unclear, I'm not going to assign any late penalties or anything for that, because again, it wasn't just 1 or 2 students; it was a few. So, so just make sure that you've got that. Okay. Now, that being said, I'm assigning homework 7 today, and homework 7 today, you're actually not turning in any Word documents. You're turning in nothing but M files. So make sure that your M files are in the network drive when you turn it in. Okay. So there's that. Okay. So, like I said, if you haven't gotten your M file into the network drive by now, no big deal, but we do need it to grade. What's that? Okay. Now, this homework assignment that I'm giving you all today has 3 different problems on it, and they are all M files. So there's 3 different problems, and you'll create an M file for each one. So. And it's all on plotting, essentially. So a lot of this stuff that's in this current, or in this homework assignment you have, we're going to discuss today. So while you all are getting set up, you might as well go ahead and open MATLAB. We're obviously going to be using that today, so go ahead and get that open while I pull up the lecture notes. Let's see. Any questions about anything? Everybody good? Anything at all? Everybody's getting excited about scheduling. That's what it is, right? You can see you're having a hard time containing your excitement over all of it, right? Come on. All right. Okay. So today what we're going to do is spend most of the lecture focused on plotting. Before we do that, though, we do need to sort of go off a little bit on the side and talk about element-by-element operations, and specifically how the dot operator will affect how you perform computations in MATLAB with arrays, with 1D arrays. Remember, last time we talked about not just creating a variable with a value in it, but a variable with a table of values in it. And we started off with one-dimensional arrays, which was just a row or a row of values or a column of values. Next time, or probably next time, or maybe the time after, we'll discuss two-dimensional arrays. But we walk before we can run. You know how that goes. Okay, so let's just keep it simple for today. Now, I want everybody to go into the command window, and I want you to follow along with me. Okay? So last time we talked about the creation of 1D arrays. Okay? Now, you'll have to forgive me. I'm going to call these vectors here and there. So if you ever hear me use the term vector, I'm basically just saying a row of numbers or a column of numbers. It's another fancy term for that. Now, we also mentioned how vectors are useful in plotting. Remember, we had a plot x comma y command that we had in the last lecture, and I kind of just glossed over and I said, oh, here's a plot, let's move on. Today we're going to spend some detail on actual plotting. Now, let's just keep this simple. What's the graph of y equals x squared look like? It's a It's a parabola, right? So let's go into the command window. Let's do this. Now, I want you all to start off by creating this vector right here. X equals from -5 to 5. So pop quiz, if I was creating that vector, what would the increment be from each term? What's that? 1, because there's no central number. It automatically assumes 1. Okay? So you all do that. Okay? So when you do that, you should have a vector which I think it has 11 terms in it, right? It should say that on the side. Or you can open up and literally just count it. Okay? Now, what I want you to do is I want you to do that. Y equals x squared. Is it getting upset at you? It got upset at you, didn't it? Okay? Specifically, it probably spit out a message that looked something about like that, right? Okay. There's a reason why. Okay? When you said y equals x squared, I want you to think in your head, what did you want MATLAB to do? You wanted MATLAB to take each one of those numbers and square it, right? So the -5 squared, the -4 squared, the -3 squared, the -2 squared, the -1 squared, etc., right? That's what you wanted MATLAB to do. Unfortunately, that's not what you told MATLAB to do. You told MATLAB to take the vector x and multiply it times the vector x. Okay? Now, do you all remember, maybe it was in high school, maybe it was in algebra here or pre-calc here, do you all remember ever doing matrix algebra, matrix multiplication? You all remember that? You know, you had the rows and the columns and the rows and the columns and you track it down. You all remember that? Well, by just saying y equals x squared, MATLAB treated this like it was a matrix, and it said, okay, this matrix times this matrix. And the problem is the dimensions of the matrices, they don't really work out. So so right off the bat, that multiplication is no good. However, MATLAB was a little smarter than that, and it recognized, you know what, that's probably not what you wanted to do. You probably wanted to take each element and square it one at a time. And if you notice, it says you could use the power command, or you could do this little dot caret. Okay? We need a way to perform element by element operations for a given formula, especially when we're doing plotting. So what I want you to do is, instead of doing y equals x squared, I want you to do y equals x dot caret squared. I want you to put a dot in front of it. Now try it. And don't put the colon there. I want to see the output. Did you create x? No, you've got to create the x. You got to do that. Okay. One thing on yours, you used a comma. Right here, you need to use a colon. I want the whole thing. Okay. So if you did that right, you should get a big table of numbers that looks something like that. I want to make sure everybody's getting this. Is everybody getting that? It should say like 25, 16, 9, 4, 1, 0, 1, 4, 9. Everybody getting that? Everybody not getting that? It's okay if you're not. Everybody good? Okay. Now what you can do is go in and plot it. Now I want to be clear so everybody's aware of this. There are 3 operations that need to have a dot in front of it if you want to perform those element by element operations. You need a dot in front of multiplication, a dot in front of division, and a dot in front of exponentiation. Okay? Addition and subtraction, you really don't need dots in front of that. You just got to make sure the size of your matrices work. Okay? Sound good? Okay. Now, all right. This is a point right off the bat. If you're performing element by element operations on 2 vectors or 2 arrays, they got to be the same size. So look over here in the top right. So I've got that A is 1, 2, 3, 4, so it's got 4 terms in it. And then B's got 5, 6, 7, so it only has 3 terms in it, right? Now if I try and do dot multiplication, what MATLAB's going to do is it's going to try and do element by element. So it's going to say 1 times 5, 2 times 6, 3 times 7, 4 times, there's nothing there, okay? So if you want to do element by element operations, that's fine, but they've got to be the same size, okay? Does that make sense? Now, if you had like a vector just times 4, that would be fine. Okay, so does that sound good? All right. Now, you also don't need to do those dots anytime that you use a MATLAB function. So, for instance, if I have a equals 1, 2, 3, 4, and I just take the cosine, it'll just take the cosine of each element. So you don't need a dot operator for all of those. Okay, does that sound good? Okay, so ultimately you should have something like this. Now, what I want you to do before we move on, I want you to recreate that x vector, but instead I want a finer step. I want a step of 0.1. So instead of -5, -4, -3, it'll start at -5 and then it'll go -4.9, -4.8, -4.7. So if you notice, this vector should have a lot more terms in it. Again, don't forget your semicolon, or when you press enter, it's going to spit out a bunch of stuff at you. Okay? Now that you've recreated the x vector, I want you to create a new y vector, a new y equals x squared. Again, don't forget your dot. Y equals dot, or x dot raised to the second power, so it's going to square each individual term, and then plot it. Okay? Now, if you do that, you should get a parabola. So I'm going to look, make sure I see the parabola on everybody's screen. This is one of those interactive things. I want everybody doing this together. See parabolas everywhere. I want to see the parabolas on your screens. There's a parabola. Is anybody? If you're having issues, no big deal at all. So. There we go. There we go. There we go. There we go. Are you good?
Yeah.
Okay. Okay, good. All right, so you should get something that looks like this. Okay? Now, I don't know about you, but I think this leaves a lot to be desired because there's a lot not here on the plot. There's no x-axis label. There's no y-axis label. There's no chart title. There's no legend. Remember all the stuff that we could do in Excel? It's not here, right? We need to talk about how to create a plot and how to format it the way that we want, okay? So I'm going to show you all a couple things. Just a heads up, I'm going to show you all a couple things, and then we're going to have a quick exercise where you all are creating a script file in class. So you want to make sure you've got a folder or you got your flash drive or something like that, because we're going to be using it here in a little bit. Okay, so let's take this plot and let's change it up a little bit. Okay, now the first way that we can change that up is to use what's called a line specifier. Now a line specifier, basically all that does is it changes the way that this line looks. Notice how this line is, it's what kind of blue, and it's a solid line, right? Well, we can change that pretty easily through a line specifier. We can make it a dashed line. We can make it a green line. We can put markers on it and what have you. And that's pretty easy to do if you understand the syntax. So this is something everybody's going to want to pay attention to. All right, so first off, to specify the line style, what you would do, or what to do a line specifier, you would say plot x comma y and then comma some identifier. Okay, so first off, for line style, there's 4 of them. You can have a solid line, a dashed line, a dotted line, or a dash dot line. So if you go back to your command window and instead of saying plot x comma y, say plot x comma y comma, and then put this string, 2 apostrophes and then dash dash. What MATLAB's going to do is it's going to interpret this dash dash symbol to mean that I want this plot to have a dashed line. And if you hit enter and go back to your plot, it should have changed and you should have a dashed line. So I want to see if everybody's getting that dashed line. Everybody getting that? So you could play around with this. You could put instead of 2 dashes, you could put a colon in there and you would get a dotted line. Okay? So Everybody be, able to sort of mess around with that? Okay. Sound good? All right. The next thing you can do is you can put some markers in it. So I'm going to explain what this string looks like here in a second. But I've got a number of different marker options. I could put circles, plus signs, asterisks. Why don't I open up MATLAB and sort of play around with this with you all. So here's MATLAB. So clear that out. So what we have, x equals -5 from 0.1 to 5. Y equals x dot squared. And then plot x and y. Okay. Okay, so here's my figure, and I can go in and play around with this. So for instance, we talked a second ago about how we can do something like 2 dashes, and that'll make this a dashed line. Let me see if I can sort of move that over about like that, and maybe, I don't know, squunch this up a little bit. There we go. I think that's good.
You're doing like 2 dash lines to make it dotted and red, and you do 2 slashes and R, or do you have that?
Yeah, I'm going to get to that here in a second. Yeah. All right. But give me one sec. We will get to that. So if I did this, notice how it turns it into a dotted line, and so on and so forth. So let's just go back to what we had. Now, to do markers, all you do is place the symbol of interest. So for instance, if I have for instance, a 0, that's going to replace the line with a bunch of markers. Okay? Everybody see that? So if I want markers and I want a dashed line, I might do something like this. I might say markers and a dashed line. I would do this. And you'll notice if you look behind, you can kind of see I've got the markers and I've got the dashed line. Now, I think this might answer the question that you were talking about. What is the difference between, let's say, this command and, let's say, this one? Let's say this. In other words, does it matter what order your identifiers are? Like, do you have to have the O first and then the dashes, or the dashes and then the O? It doesn't matter as long as you just use the right values. Okay? Everybody okay with that? So I can mess around with this. I can say, you know what? Instead of O's, I want plus signs. And notice how it changed the graph, and they're all plus signs. Does everybody see that? Okay, and you should notice there's a whole bunch of identifiers on your slide. Let me pull the slide. Yeah, so I mean, you've got diamond symbols you could use, you've got squares you could use, you could put triangles, you could have these each be little triangles. You can format the plot however you would like. Okay? Now going into color, you could go in and you could say, all right, let's do x comma y and let's put an R, and that'll make the curve red. So if you wanted R and then, let's say, dashed lines, you could do R dash dash or dash dash R. It wouldn't matter as long as you've got the code specifiers. Did that answer your question?
Yeah, I tried to do it.
It did?
Yeah.
Okay, good. All right. Now MATLAB has some pre-built colors into it, like yellow and red and green and black and cyan and things like that. So you can go in and sort of play around with that. If you had something like, let's have some fun with this. So let's go to MATLAB. You know, let's say we had this. We had RO dash dash. So what that's going to do is it's going to make a red line with circle markers, and the line itself is going to be dashed. Does that make sense? So you can, play around with the formatting however you'd like. And again, the order doesn't really matter as long as you're using the right codes. And that's why I sort of summarize them on those slides, so it's all right there. Sound good? Okay, now you can really have some fun with it later by using some property modifiers. Okay? Now for property modifiers, there's 4 of them. There's line width, there's marker size, marker edge color, and marker face color. So this is a long one, but I want to let's just sort of look at this code right here. Let's see if we can interpret what it should look like, and then let's see on the end what it ends up outputting. So let's look at this. Okay, everybody follow along with me up here. So we're plotting x and y. Now this code right here, dash MO, what does the dash mean? You tell me. What's that? And what line type is a dash? A single dash. Hold on. What line type is a dash? Solid line. Okay. Everybody okay with that? All right. What does the M mean? Go through your slides. Tell me what it means. Magenta. So it's a magenta line. Okay. What does the O mean? Circle markers. Okay. Now we've got a line width of 2. So if the default is 0.5, that means the line itself is going to be a little thicker, right? Okay. The marker size is going to be 12. Those are measured in pixels, by the way. So 12 pixel markers. Now look at this. Marker edge color and marker face color. So the edge of these markers are going to be what? Green. What are the center of those markers going to be? Yellow. And so here's what we've got. Okay, so this is what the curve looked like before. Here's what it looks like now. And if you look at it, it all kind of makes sense. We have a solid magenta line with circle markers, right? We've got yellow fill with green edges. The marker sizes are 2. The line width's 2. Everything sounds good. Any questions? It gives you a little bit of control over what you're doing. Well, if you're okay with that, then let's break out some scripts. All right, so I'm going to give you all a couple minutes. I want you to work on this. So I want you all to write a script file. Now, if you're doing this in the command window, you're doing it wrong, okay? Because I want you to open up a new script file on the top left, write this out, and then save your results on a flash drive or your V drive or something like that. So you should be opening up a new script and writing this. So let's take a look at it. The table below contains data from a company's sales, so from 1998 to 1994 in 1-year increments. Nudge, nudge, wink, wink. You shouldn't have to type all those numbers in, right? And here are the sales data, 8, 12, 20. So this is how much the company's made. I want you to create a plot. And I want you to do this. I want a dashed red line with asterisk markers, and I want a line width of 2 and marker widths of 12 points. So I want you to specify all that and go to work. Tell me what you got. Now again, if you're working in the command window, you're doing this wrong. If you're in the command window, you need to be in a new. There you go. There you go. You all can work together. I mean, it's not a pop quiz or anything. I don't have a problem with that at all. Everybody's all freaking out. MATLAB will not bite. I promise. I feel like I should walk up and just go, boo. Where's your script? No. I mean the one that you were talking about last time.
If I do it in the command window, it saves it.
Oh, no. But you have to run it.
It wouldn't even save it.
Can you put that like call that file trial or something and put it somewhere where you can find it? Then hit change directory. Yeah.
Okay.
Yeah, that's all it is where you have to actually run it. So I bet you your file is probably just fine. So that was it. Now, I noticed some of you create using a vector creation for this, and that is the correct way to go. I mean, I wouldn't type all those numbers in if I could avoid it. However, what's your increment in between each of these? Do you need to actually type out the 1? No, because the default increment is 1. So there's nothing wrong. You can put the 1 there. That's fine. It's not going to make anything incorrect. Just make sure that's, you got to put another apostrophe on the end. So. While you all are working on that, I will open up MATLAB. So I'm going to create a new script. And so we'll start off with the vector creation. So the vectors, you should have x equals, we'll say 19, or here, I'll put a bracket on it, 1988 to 1994. And there you go. Now, MATLAB has figured out that you technically don't need the brackets if you only have a one-dimensional array. You can leave them there, or you can delete them. It doesn't matter. So I'm actually going to delete them. Now, your y vector, you can separate your values one of two ways. You can use commas or you can use the space bar. It doesn't matter. So you could do this. 8, 12, 20, 22, 18, 24, 27. Commas and spaces will work just fine. I actually prefer commas, but if I'm doing something quick, I'll probably use the space bar. Yes, sir.
You don't have to put apostrophes on it.
No.
And stuff you do.
The reason why is because anything that's not a number is going to be treated as a string, and MATLAB will interpret strings once you put the apostrophes on it. But if it's just a numerical value, that's a good question. So more often than not, when you're dealing with numbers, you don't need the apostrophes more often than not. And whenever in doubt, always go to the documentation. I mean, it will literally tell you step by step what to do with every command. So, but as a rule, generally you don't need the tick marks for numbers. So I want to see if everybody's generating the plot. So make sure you save this script. We're gonna do some more editing to it. So we should have plot x comma y, and then what do the instructions say? We've got a dashed red line with asterisk markers. So what should we have? We should have a dashed line, red, and asterisks. So that'll give you the dashed red line, right? Now you all finish the rest. Yours looks good. You're going to go up a little bit. Yeah, you've got it. Do you have your line width and your, see, line width, the 2-point, marker width, the 12 points. You call it sales. All right, hold on. What's that? Marker size. Yes. Did you run it? You got to save your program somewhere. Remember, when you're writing a script, you actually have to run the script for the plot to show up. Okay. There you go. I want to see the graph popped up on everybody's screen. You can call it whatever. Sales. Just make sure whatever you call it that you're following the rules of variable naming. You can't have any spaces in your file name or it's not going to run. Yeah. Yeah. That's right. Oh, but well, first, okay. One thing, all of these specifiers should all be in the same line. In other words, you shouldn't be going down and doing like this. Like you shouldn't have another plot command down here. It should all be in the same one. Like you should have line width of 2 and then just trailing on with the same one. Otherwise, MATLAB's going to overwrite your plot command. So it needs to be all on the same line. Yes? You have an extra marker? Nope. I mean, you have an extra marker. No, wait, hold on. Oh, that's what, yeah. Yeah. All right. Hold on. What's up? Okay, again, you're using 2 plot, like you shouldn't be using 2. You should only have 1. And you got an extra comma.
Had a space between?
No, you had a comma right there. It was looking for something else. So you got to delete that comma. All right, hold on. What's up?
Oh, when I run it, it doesn't do anything. It just says sales.
All right, I want to see that figure popped up on everybody's screen. Remember to run, you got to hit run to run. Yeah, there you go. All right, are you good or? All right, here's the reason why. You don't have a comma. Wait. Now what happened?
I think that's marker size,
Yeah,
right?
that's marker size. Because if you look, you have your notes popped up?
Yeah.
See, it's marker size, not marker width. Now run it. There we go. You got yours run, or there we go. Does everybody have theirs? Who doesn't have it? Are you good or? Unable to run. Oh, you put a space in your file name. You can't have spaces in your file name.
Okay.
Save it again as something else. You have yours? What is? Let me see. Yeah, let me see. It looks right. Try and run it. No problem. You got yours? There we go. All right. You all have yours? You got yours? You got yours? You two have yours? You two have yours? All right. See, all right. Everybody good? See, that's not so bad, right? It's simple, okay? So now what we're going to do is we're going to take this script that you've written and we are going to flip the script. No, I'm just kidding. We're going to take it and add to it a little bit. Okay, so I want to, I guess, show you all a couple things, and then we're going to add to this script. So we're going to have lines going below this. Okay, so a couple things. First off, you can actually plot multiple things on the same graph very easily by just, going on with your variables. Like you have plot. If you had something like plot x, comma y, comma a, comma b. What it's going to do is it's going to create a line of X and Y, and a line of A and B. So you could keep going on as many times as you wanted if you had, 4 or 5 different data sets that you wanted to plot onto the same graph. Now, the downside is if you just want a quick plot, that'll be fine. But if you want a little more control over your formatting, you're going to want to use what's called the hold command, and we'll talk about hold later. But you can do some pretty basic formatting in this fashion, like you can have X and Y, and then we'll have a solid blue line, A and B, a dashed red line, T and H, and a dotted green line. You can go through and do that. Okay, now let's do a couple things, or let's talk about a couple things. So first off, this graph is fine that you all have, this dashed asterisk graph, but it doesn't really have much in the way of information. For instance, it doesn't have any labels on the x-axis or the y-axis, so you would go down on lines below and just type in X label and put in whatever you want. So here's a for instance. I'll just show you real quick how one of these works. So let me pull up MATLAB and let me go to my script. Okay. Now what is on the x-axis for this plot? What's on the x-axis? Years. Okay. So if I did this, if I went in and I said, okay, if I go down and I say X label and I go years and just did that, and then run the command. Actually, I need to save this. Let me save this on my, where's this? V drive, MATLAB. We'll call this sales. All right, let me run this. And you'll notice here on the bottom, it has now placed a label. Right? And it says years on the bottom. So I can go in and I can say, let's put years on the bottom. What goes, or you tell me, what goes on the y-axis, or what should go on the y-axis for this plot? Sales in millions, right? So I can label the y-axis very easily. It's not that hard. Okay? I can also go in and put a title on the plot. I can say comparison of ABC Engineering sales for the past few years, or whatever I want to title it. I could put in a text box on the plot. I could just say text box, type in the X and Y coordinates, and type in whatever I want it to say. I'm not really going to worry about that for this, but I just wanted you all to get some basics. Also, legend. Okay, legend is really important, and we're going to use legend here in a little bit. But if you have 2 different data sets on your plot, then you might want a legend. Like you might say, okay, these are the sales for bulldozers, and here's the sales for dump trucks, So you'll want to label those accordingly. And the way it works is your labels should correspond to the order that you programmed it. Like if you plotted your bulldozer sales first, put your bulldozer label first, and et cetera. So it's pretty straightforward. Okay. Sound good? All right, so a couple other things. Okay, so axis, okay? So you can change the bounds of the axes pretty easily. So for instance, for our plot, the x-axis, it goes from, 1988 to 1994. I can make it go from 1980 to 2000, and then the graph would only occupy a very small amount of space. But the syntax is xmin, xmax, ymin, ymax. Pretty simple. I can also have equal grid spacing, square grid spacing. This is important if you want the proportion of your graph to be square. You want the same scale on one axis than you do on the other. And you can also turn the grid on and off, the plotting grid. And we're gonna play around with this on this script. In fact, why don't we do this? Okay. So here's the plot, the one we just did. I want you all to add some labels to this. So you all know how to label the x-axis year. I want you to label the y-axis sales in millions. I want you to title the plot sales data for ABC Equipment Incorporated. I want you to set these axis limits, and I want you to turn the grid on. And all you have to do for that is literally just on one line of the script, just type grid on, and that's it. So on each, you've got lines on, or code on lines 1, line 2, and line 3. Just go down line 4, line 5, line 6, and start typing all this stuff in. Again, each time you type a line of script, run your program and see what you get. While you all are doing that, I'm going to X something out. Let me see something. What is it? It's 1987. Oh, one thing on your axis, let me show you something. On your axis, it's going to treat that as a vector, so make sure you have braces in between these numbers right here, so make sure you use those square brackets. And then that'll fix your axes. So does everybody see that? Make sure you have a square bracket here and a square bracket there on your axis. Oh, honestly, I should change that on the lecture notes. I should go in and right here, I should say, you know, bracket there and bracket there. I'll do that when I get back to the office. So yeah, so I want to see that title. I want to see the X and Y axis labeled, and I want to see the grid on and those axes changed. The only thing you're missing is a title. Okay, so you need your axis and your grid. Make sure you have a inside, you have a square bracket there and there. See, let me pull that up so everybody's got that. That was a mistake on my part. Of course, I'm allowed 7 mistakes a semester, so I think I'm doing pretty good. That's policy according to Marshall. That was a joke, not a very funny one. There you go. See, this really isn't that bad, right? Once you know the syntax and know what functions go where, it's really pretty simple, isn't it? So while you all are working on that, I'll sort of finish it and give everybody a target. So let's see. Sales data. More. All right, so axis. Let me close that and run it. So your plot should look something like this. Oh, I forgot my marker size. So this is what your plot should look like. Make sure it'll give everybody a target to look for. So let's see how everybody's doing. Doing good, doing good, doing good, doing good. There we go. There we go, there we go. There we go. There we go, there we go. There we go. Okay, you need a title on yours. You've got a title. Good, there we go. There we go, there we go. How's yours? Where's the graph? That looks right.
It doesn't have any.
I'll look at that here in a sec, all right?
Still plugged in.
Looks good, looks good. Looks good, looks good. Let me see yours. There we go. All right, real quick, I want everybody to open up Microsoft Word. I want to show y'all something real quick. All right. Has everybody got Microsoft Word open? All right, just open up some blank document. Let me show you something real quick. If you go on to Figure and you go to Edit, go down to the Edit command. See where it says Copy Figure? Okay, you can copy the figure, and when you go to Word, you can actually paste in that image, so you don't have to screen clip or anything like that. It's pretty slick. So you can hit Control V, and bam. So there's your figure. So it gives you a nice plot for some report or some presentation or what have you. Works out really nice. Honestly, I actually, I used to like Excel plots better. I thought they looked better, but with newer versions of MATLAB, I'm actually starting to change my mind. I almost think these plots look a little cleaner and look a little, the formatting looks a little better. That's just me. One thing, just as a heads up, you can go into Edit, and you can go to Figure Properties, and you can actually go in and change some of the properties of this figure. Go in and actually physically change the text, go into Sales and change the axis, and what have you. Very similar to what you had done in Excel. I actually don't recommend editing figures this way. I mean, it's fine if you've got one figure that you're trying to produce, but it's very common in MATLAB that, let's say you're doing some experiment or you're doing some data analysis. It's not that uncommon to get MATLAB to produce like hundreds and hundreds and hundreds of different images for you. That's actually pretty common, and it's one of the strengths of MATLAB. The problem is if you have to go in and edit every single image to the way you want, well then you're sort of you're missing the point of MATLAB. The point is that you can write a program to spit the pictures out the way you want and then just hit go, and then now you have 100 graphs. I mean, imagine if you had to create 100 plots in Excel. That'd take a long time. It really wouldn't take a long time in MATLAB because all you have to do is just hit a for loop and press go and it'll just do it. Okay? Does that make sense? Everybody okay with that? All right. Just some points to get out there. Okay. So yeah, you can go in, hit copy figure, and that'll go nice into a presentation or whatnot. I mean, that's how, like for instance, when I went back here, that's how I got these plots into this PowerPoint. Is I just hit copy figure, so they're all the same size, they're all formatted nicely, and it comes out looking very cleanly formatted. Let's see, I mentioned figure properties. Okay, now as stated earlier, you probably will want more control if you're trying to plot things, plot multiple data sets on the same plot, and that's where the hold command comes into play. So let me show you how this works. Okay, so the first thing that you will do if you're trying to plot multiple data sets is do what we just did. Plot the first data set and format it the way that you want. Okay? Once you've done that, you're going to insert what's called hold on. Okay? So here's my code. So I did a little bit of work. Getting this one data set to plot the way I wanted. Then what I'm going to do is I'll go down a little bit and I'll say hold on, and then I will do some more plotting. And what I will do is once I do that additional plotting, it'll all show up on the same chart. Let's just sort of play around with that and see how that works. Okay? And we'll do this one together. Okay? So let me show you how this is going to work. I want everybody to watch this, and then we'll play around with this. So all that stuff that we've been plotting just now, I'm going to say that that was excavator sales, okay? And everything afterwards, this column over here on the right, we'll say that that is crane sales. So this was our original data set. This was what we were dealing with a second ago. I'm going to create a new data set and call it crane sales. So I'm going to have more data to plot. Then we'll see what this looks like when it's all done. So I'll do this one with you just to make sure everybody's on the same page. So here's my MATLAB. So I hit hold on. I'm going to define a new vector. We'll call this one, we'll call it y2 equals, and then I'm going to go in and enter these crane sales. So what do we got? We got 7, 14, 25, 18, 18, 26, 23. And then close that up. Okay? Now, see up here where I was plotting x versus y? Now I'm going to plot x versus y2. Okay? So we'll say plot x versus y2. Okay. Now, I'm going to go ahead and just right now go ahead and enter in my hold off and hit run. Now look what happened. See what it did? It plotted on top of the graph that we just created. Does everybody see that? Now, watch what happens when I remove hold on and hold off. Now, I'm not going to delete them. This was that debugging trick I told y'all earlier. I'm going to go in and comment them. So now MATLAB is not going to execute those lines. So if I hit run, now look at what my figure looks like. You want to know why it looks like that? The reason it looks like that is because we did a plot command, and then we did all this stuff to format that plot, but then we hit plot again. And once we hit plot again, MATLAB said, oh, forget all this stuff. This is the one that matters. But that hold command and that hold on and hold off, what that does is that locks all this stuff into place so that I can go in and do more plotting onto that same figure. So that's why when I run it with the hold on and the hold off, everything that I did before sticks. Okay? That makes sense? All right. So a couple other things I want to do to this. So what do we need to do for this data set, this second data set? What does it say? We've got a solid black line with circle markers. So how do we do a solid line? What's our identifier? 1 dash. Okay. Black, what's the code for black? K. And that's because blue is B. So circle markers. So a 0, right? Okay. So we're going to use a line width of 12 points and a line width of 2 points and a marker width of 12 points. So I guess that was kind of mean because I said marker width instead of marker size, but that's trying to get everybody to look at the slideshow. So we have a line width of 2, marker size of 12. Now let's just run it and see what it looks like. Okay, there we go. So now you can see what happened. We have a solid black line with circle markers, and the marker size is 12. The line width is 2. So everything is formatted the way I want. Now let me ask you this: what is the one thing that this graph is missing? If I was going to give this graph to somebody down the hall and they didn't even know what we were looking at, what's the one thing this graph is missing? A legend. They don't know what each of these are. So what I'm going to do is this. I'm going to go in between this hold on and hold off. Right here, in between hold on and hold off. Let me close my figure. And I'm going to go in and I'm going to specify a legend. Now, which data set did I plot first? The excavator sales or the crane sales? The excavator. So I'm going to do excavator, crane. And if you want, you could put excavator sales. Sales. And run it. And there you go. Now that's a better figure, right? Now I'll admit the lines look a little cartoonish. They're really big, and personally I probably wouldn't format lines that way. But the point is so that we all have control over how those lines are formatted. Make sense? It's really not that bad, right? It's pretty simple. It's pretty straightforward. If you've done all of this correctly, then your plot should look like that, okay? So it's not so bad, right? It's just all about learning the syntax and making sure you understand what each line of code does. Sounds good? Now, let me be honest with you. There is a whole host of stuff that we didn't talk about with plotting. We did not talk about how to change your font. We did not talk about how to include Greek letters. If you go through in engineering, you'll find we tend to use Greek letters for a lot of things because there's only 26 letters in the alphabet, and us crazy engineers come up with more than 26 terms that we need symbols for. But changing the grid spacing and all that stuff, I mean, there's a lot we didn't talk about. My goal is to get you all to be able to produce simple, neatly formatted, clear plots. That's what I want. The more you use MATLAB, the better you will get at it, okay? For now, I just want you to understand the basics. Sound good? Okay, so let me show you all the homework real quick. And the homework, theoretically, you could do the homework from start to finish right now, so I'm giving you a fair amount of time on it. So let me pull up the homework so that everybody's aware of what we're doing. Okay, again, I want everybody to be clear on this. We are saving the M files in our network drive. No screen clippings of anything. I need the programs. I need the programs. Okay, so problem 1, I want you to write a script file that will plot that. So no labeling, other than labeling the x-axis, the y-axis, and turning the grid on, no line formatting or anything like that. Okay, I want you to plot that equation. 3.5 raised to the minus 0.5x times the cosine of 6x. So make sure you're using your dot operator accordingly. Okay. Second problem, I'm giving you a data point. This problem is looking at an experiment which measured light intensity over a given length. I don't know how much that really matters, but I've given you x values and y values. So this is the experimental data. This is the theoretical data. So for the variables, you should really have 4 variables that you're creating, an x and y vector for the experimental data and an x and y vector for the theoretical data. It's telling you what the increments are for all of these. Make sure you're using your dot operator accordingly. And then for the plot on the next page, there's a whole host of different things on how the axes should be bound, how how everything should be bound, etc. So, what your titles are, labels, all that. Okay, so problem number 3. Problem number 3, you're given a data set, and then I actually want you to go back to that previous lecture and use some of the polyfit commands to fit a polynomial to that data. So let's actually look and see what the data looks like. So there's your x values and y values. I want you to plot those data points, and then plot a line and a parabola to see which one fits the data best. Let's see what else. The last thing is, so there's a line and a parabola. Whichever one you think fits the data best, I want you to use that function to predict what would the value be at x equals 4.25, and then assign whatever that is to the variable c. And then that's it. Like I said, you all can do that now. Like, you all could actually go through and specify that right now. So, sound good? All right. With that, I'm going to shut up and let you all spend some time working on this homework, and that's all I got. So I will see you all next week, I guess. All right.